Hey, what is good, you guys? Welcome back to the channel. I hope all of you are well. And today going to be starting a brand new series on unit testing in Python. So this is the part one of the series, which will cover the uh, unit test module, which comes in as part of the standard Python distribution. And in part two and part three, we'll be talking about doctest and PyTest. Uh, so PyTest is a third-party library which is used for testing, and I think it is the most popular one in today's Python test world. But let's get started with the basics first, the one which comes built in. Why do we why have to install when most of the stuff which we need does come with the standard distribution unit test module? So with that being said, let's get started. Right, as per the format of our video, first things first, why we need unit tests? The answer is pretty straightforward. I don't think we have to go into detail. There's a couple of main advantages. The first one is obviously they help us catch the bugs early before they go to QA or prod. So this reduces the time needed to make a code live, or the time to market, or the time to production, as we say. Catching bugs early is essential to setting up faster deliveries. And in today's world, when features are requested very often, we are in an agile world where we do deployments very often, say every week or every couple of weeks, where we see new features coming up on products or apps, whatever you're writing. It's essential that developers write as many unit tests and test as much of the functionality as they can before giving it to the QA, and before they do their work and move the code finally goes to production, and there are almost zero or as less as possible bugs. And to catch them early, it is essential to have a healthy a healthy test coverage, or a well-written unit tests to cover each and every functionality. The second one is obviously as an added bonus, and that is testing helps us uncover or understand the performance of, not the performance, sorry, I think that's not the correct word, but behavior of our code. So if you write a code and then you write a test case, I think that is something which is kind of phasing out. We are moving into a test-driven development mode, wherein you write the test first, a test to fail, and based on the test, you then write the code, then go and write the code, so that the tests then pass. So this is the test driven development model. And what advantage it gives us is it helps us to understand the behavior of the code, and whatever we are writing is exactly what we intended the code to do. So the TDD model, which is becoming more and more popular, gives us that advantage as well. Not only TDD, but any test which you write helps us to understand the code better. And the third and the last advantage is that it gives us confidence in what we are building. So when you write tests to explore the functionality, or to test the functionality of our code, and it is working as expected, the test results are in line with what we expect. It gives us confidence to ship the code and reporting of minimum bugs. So those are the few advantages which I can think of and are the most important. But I don't think unit testing requires any explanation of advantage. With or without advantages, people should write unit tests. Right, enough of the theory. Let's jump to PyCharm and start writing some unit tests. First things first, when you're testing with unit test or PyTest, the file name has to start with a test underscore to help the discovery. So what I mean by discovery is when you run the unit test module, it has to find the files. So there's a couple of ways to do it. One is using the PyCharm configurations, and the second one is using the command line. And to do that, you have to name your files starting with test underscore. So I'm going to name the file test, something like test basic test dot py, because we are going to write some basic tests, and it's a fair enough name. So to import the unit test module, you simply have to do unit test. It comes inbuilt with the Python standard distribution. No installation is required. And where it comes from, or where the idea comes from, is from the JUnit. So if you're from the Java world, JUnit is a popular testing library. I think at least it was. I'm not sure. I've not updated myself with Java as much. Right. Enough of the theory. Let's jump to PyCharm and start writing some unit tests. First things first. When you're testing with unit test or PyTest, the file name has to start with a test underscore to help the discovery. So what I mean by discovery is when you run the unit test module, it has to find the files. So there's a couple of ways to do it. One is using the PyCharm configurations, and the second one is using the command line. And to do that, you have to name your files starting with test underscore. So I'm going to name the file test, something like test basic test dot py, because we're going to write some basic tests, and it's a fair enough name. So to import the unit test module, you simply have to do unit test. It comes inbuilt with the Python standard distribution. No installation is required, and where it comes from, or where the idea comes from, is from the JUnit. So if you're from the Java world, JUnit is a popular testing library. I think at least it was. I'm not sure. I've not updated myself with Java as much. Yeah. So what does a basic unit test look like? So it is pretty simple. Now, the thing which you first need to keep in mind while writing unit tests using the Python's unit test module is that you have to wrap all the tests or group all the tests in a class. So the first thing is test basic setup. So this is the name of the class, and it has to inherit from unit test.test case class. So this is the basic setup which you have to do. That is, all the tests should be grouped in a class. A test has to begin with test underscore. So a name of the test also has to start with test underscore first ever test. The methods don't have to don't have to take any arguments unless absolutely necessary. We'll see that in a while. But this is the setup of our basic test case. We do have our first test case ready, and to run it, it is simple. If we do name equal to, and you just have to write unit test dot main. If I now run this code, if you see, nothing is done. But if you see the left hand side, in the run section of the on the bottom side, if you see that the first ever test has run and it has passed as well, no issues there. So this is a test, does nothing, but the idea of this was to explain how to set up a test. You have to have a class, and within the class has to inherit from unit test or test case class, and within that, each and every test is then a function, and the name of the function needs to start with test underscore, a very meaningful name which indicates what you're testing. So this, I think, for our test case is more or less meaningful name. But as we progress with the tutorial, we will explore the naming convention a little bit more in detail and what a good name looks like, right? Let us put some code in our assertion, not in the assertion but the test case, because at the moment it just says pass, and obviously this test case will pass. At the heart of everything, or at the heart of every all things test cases, is the assertion. So when you type self.assert, you will see a lot of assertions which are available, which you can use to test the various scenarios in your code. So we're going to look at some of them, and if you just do a self.assert, it will give you all the assertions available and the signatures of them. So if I just do pick the first one, assert equal, and give it two parameters as it intends foo and foo. Let's just do foo. And if I run this test case now, if you see, the test case is already run and it has given ran one test. Okay, so this is the basic setup. Basic setup of a test case. This is actually a working test case, and what it does is it checks for equality. If you just click on the signature, it will also tell that it fails if two objects are unequal as determined by the double equal to. So this is a working test case, right? It checks for equality. If I just do a fool or just make it unequal, PyCharm is also telling us that the test case is in fact failed, and it will give you a failure and also why it is failed, that foo1 is not equal to foo, and also what is expected was foo, but the actual value is foo1. So it is also giving you much more in detail explanation of what went wrong. And I'm using a Python version 3.11, so the new error messages also tell me, the traceback also tells me where the problem is. So this is just one assertion, and you can just click it, and if I just run it now, if you see, it gives me a little bit the tests pass. So this is not the only way to run it. You can run it from the console as well. Run the unit test case in two ways, either from the PyCharm or directly, or using the command line as well. So on the terminal, what I can do is just do python-m unit test and test underscore basics. So the unit test will tell Python that I have to discover all the tests, where the tests are. That is all the .py file that start with the test underscore word, and if we can give the -v flag to get a more verbose was output. So if I just do that, it'll see that ran one test okay, and it'll also tell us which test it ran. So if I just there's other variables as well. If I just give locals, I think it's double hyphen locals, and it'll give us some additional details if any as well. So let us now write a second test case to explore more assert words, and this time I think we'll use a different one, maybe the in comparison, which will use to check if a particular string exists in a list or any output written by a unit under test. So test word in list of words sounds like a good enough name, and self dot assert, and we'll choose assert in this time. And what I'll do is the word cherry in, say this is a list of names, and if I just give it a list of names, and if I now run the test case, let's see what happens. If you see the test word list has also passed again because the first test was not showing. So I've saved it again, and if you see, both the tests are now passing. Now if I just fail this test one, and if I just do this and run this test again, and if you see the second test has failed, so if you click on this, it'll tell you as well why the test has failed. So the word Jerry one was not found in the list, and the first test case is running as expected, no issues there. So the left hand side module will also tell you why the tests are failing and which of the tests are failing. If I just run it now with locals, let me give it a double hyphen, I think. And if you see, it ran two tests, so the command line is useful as well. It ran two tests, well, one of them passed and one of them failed, so there's only one failure, and which failure is shown as well. So the command line is useful if you are using the test case module in the CI/CD pipelines, because the run option is not available there. And when you're writing CI/CD pipelines, you can just choose to write the command lines which we showed here. Now, this is not the only way. I mean, as I mentioned earlier, what if we just want to run a part of the test? Obviously, you can just click here and run the single test, and it'll run the single test. If you just do this, and it will run the single test. On the terminal as well, or on the command line, you can run a single test by calling the same python-m unit test, the name of the module test basic, and the name of the test case, which is name of the class rather, test basic setup dot the test you want to run. So if I just do a test first ever underscore test, so it will run only one test. And just to see that we actually did only run that test, I'll give it a name, and if you see, it only ran that test case. Similarly, if I run the test word in list of words, so if you see, it has failed, and it'll also show you which test has failed. So that is a couple of ways to run it. You can either run it using terminal, which is useful in CI/CD pipelines, or using directly. You can just click on the in the test file. You can just click run, and you will see the outputs as well. On the left side, you will see details of which test has failed. Right. Let us quickly write a couple of more tests, because I think these are again pretty simple. So if you want to uh, test if input is of particular class. So if you want to test assert is instance. So if you want to test a particular input which is coming, but not input, but particular output which is coming from a function is of a particular type. So for example, if I want to check if Jerry is of the type string, I can do that as well. Because we don't have a sample class, I think we can write one quickly. So this test, let me save this and run it again. And if you see, okay, let's first get this passing, and let me run this again. And if you see, uh, all the three test cases has passed, and this is also working. So if the test assert is instance allows us to test if a particular the particular data or returned by a function is of a particular class or not. Along with that, you can also check test for error messages. So if I not error messages, but the log messages which are returned. So if you are writing a code which doesn't return anything, but just does some action, and you want to test the final log, test log as well. The setup for logging is a little bit different. So what I'm going to do is I'm going to copy paste the code and let me set up a logger. So import logging, and logger is equal to logging dot get logger, and name test basics basic tests. And I don't think that's a good name, test basic tests, but it is what it is. And logging dot basic config format is equal to what do we want to give to this one? Let's just take uh, time, and message, and give the default level is equal to logging dot debug. Right. So if you haven't checked my tutorial on logging, I have done an entire series on Python logging as well. Do check it out. So if this lines look alien to you, you can check that out as well. Now let me just copy this name. Makes life much more simpler. So to assert logs, the code which you write is slightly different. You have to use a context manager, and to the context manager you give the name of the logger. So the name of our logger is obviously test, the level which you want to test, and just give the name to the context manager as usual. This is not something which is different. And secondly, what you have to do is print a log. So this is an info message, and then the context manager has a records attribute which is a list. We take the so if I just uh, print lm.records, and if I now run this test case, right, if you see, the output of lm is a list, and at the first instance, this is where the message is. So what we're going to do is we're going to extract this message, and to do that, the way to do that is call the context manager dot records of 0, because we are extracting this particular record, and call the get method, get message on that. And after the get message is available, then we do an assert equal if the message which we passed is equal to the message which actually came back. So that is the way to assert logs. First, you have to instead of you have to use the assert logs module, give it the logger, the level, and on the context manager variable, you can just call the get message variable. You can call the get message method, and then compare the log as well. So this is another variation which you can use to test log. Right, we have seen the basics of the test case, how to set up a test case, how the file naming convention should be, and how the test should need to be put in a class which inherits from Unittest.test case for our tests to be done. Also, the name of each and every test. So a test case is just a function whose name starts with test underscore, and if you just do that, then the Python's unit test module would be able to auto detect all the test cases and run them for you. Now let us move on to some advanced concepts, and those are the test fixtures and anatomy of a good test case, or what a good test case should look like. For that, what I've done is I've taken an example, and I've written two classes, and we're going to try and simulate an e-commerce website which we are going to test. So very basic, not that we're going to build an Amazon or a Flipkart, but just borrow some ideas which I think the e-commerce website might have. So I've written two classes. One is the product, and there's an order. Obviously, I think an e-commerce website should have a product, and they should be able to take in orders. So the product class has three methods: add product, search product by name, and delete product. And the order class has two: create order and update order, which will help us to understand whether this add product is working as expected or not, search product is expected or not, working as expected or not, and the delete product, and so on. So it will give us some code base to test, and also understand some of the points which I've been trying to make about understanding the behavior of the code, how writing test case will help you understand the behavior, as well as make some changes before these bugs, or if there are any what do you say flow onto the QA or the production environments. So as usual, I think I already have the unit test, and I'm just going to write the tests here itself. So class test product looks like a good name, which will tell us that we are testing the product class. And the first one is to test the search product. First, let's do some product ads. Test add underscore product. So what the add product method does is it initializes a dictionary and it takes in three parameters: name, price, and stock quantity. And it uses the name as the key and stores the price and quantity as another dictionary. So it's a dictionary of dictionaries which is indexed by the name and has the price and quantity as the other attributes. So test add product, and I'm going to do a self. Let's just make this test pass so that if we know at least this is working. If not 8, but if underscore name equal to underscore main. I don't know why I write this every time, but and let me just run this to make sure that this test case is at least running. No tests were found. Interesting. So I've given the name correctly, and let me run this. So no tests were found. Okay, because I think we have done this name wrong. So if you see, it already throws an error if the name is not correct. So, not an error, but it doesn't find the test. It says empty suite. So right, it's now running. Test add product has run and it has passed because obviously there's nothing to do nothing to do here. So the method is called add product. So what I'm going to first do is create an instance of the product class, and then on the product instance I'm going to call add product. Let's add iPhone 13. I don't know how much it costs, maybe 9.99, and we're going to stock in hundreds of them because let's say a sale is coming up and we're going to do heavy on just be heavy on our stock. And what this add product does is then it returns the product dictionary dot name. So whatever product we just inserted, it returns. So let me just print this before and let's see what it actually does. Now if you see, it has returned the price and the quantity, and straight away you can see that just because we chose to write this unit test, it will uncovers a possible bug or possible unexpected behavior, that this add product method, although it does add, I think, correctly the product in our dictionary, but it only returns the price and the quantity. So what is the price and the quantity of what is this price and the quantity of? It's not even telling us that. It's not even telling what the product name is. So straight away, just by writing a test case without even assertion, we have come to conclusion, or we have found a possible bug that this data is not returned in the correct format. That is, the name of the product is missing. So let me go to the add product method and correct that. So what I'm going to do is I'm going to return the name, and then we're going to return a dictionary instead of just returning the price and quantity, and the dictionary is being indexed by name. So I'm just going to return what we have added, and let us now run the test case. So if you see, now this returns a much better data, and we actually have an idea of what we added was correct. I mean, what we supplied was correctly added, and it is returning. But having a print statement is not the idea. I just wanted to show you that how possibly writing a test case can offer the benefit of understanding bugs or it is unintended behaviors straight away. Let us now write some test cases. So what the add product does is it returns a dictionary. So firstly, what you can do is test add product returns dictionary. So what I can do is I just take it in a variable as data, and self dot assert is instance data of dictionary, right? And if I now run this test case, if you see, it is passing. And if I just do a set here instead of a dictionary and run this test case, if you see, it fails. And why it fails is that this dictionary is not an instance of in a set. If I just do uh, type of data, and if I run this test case now, if you see, it is clearly a dictionary, and the dictionary is not an instance of set. So let me correct this. So our first test case is working, we are checking that if it correctly returns a dictionary or not. Now let us write a test case which does some verification of the data which is actually being returned. So def test add product returns name of product, right? And product is equal to product. Let me create a new product and product dot add. Let's add uh, LG monitor, and let's go 10. It costs say $1,000, almost as the same as that of the iPhone. And let's call the correct method. I think add product is the correct method. And what you can do is self dot, or let me take this in a data just to be clear, product, and the name of the product is LG monitor, and data dot keys, right? So the data dot keys, because this is returning dictionary, dot keys will return obviously the name, which is LG monitor. We'll verify if the LG monitor is also the name. So I'm going to run this test case now, and the add product has failed, but I think that's okay. Let's run this test case now, and one of them is failing because this is returning a dictionary. Returning dictionary, dot keys will return obviously the name, which is LG monitor. We'll verify if the LG monitor is also the name. So I'm going to run this test case now, and the add product has failed, but I think that's okay. Let's run this test case now, and one of them is failing because this is returning a right. I think the add product is failing, but I know why that is failing. Instead of equal, I think we have to do an in. That is LG monitor is present in data dot keys. Now let's run this, and hopefully it should pass, because the test we were actually doing was wrong. And why it is wrong is because if I just do data dot keys to explain, if you see, it actually returns a dictionary of keys. It doesn't actually return the string directly, but it returns a dictionary representation, and that is why we have to check whether we have to do an in assertion instead of equal on the data.keys. So let me just remove this and run it again. Or actually, let me run this in a more verbose way. It's not test basic setup, I think. Actually, you know what? This will cost me a minute, but test e-commerce, is the spelling correct? E-commerce underscore module dot test product dot, and I can just copy paste the rest of this, and hyphen v verbose. So this test is now running okay, and it shows that it actually ran the test case which we intended to. So this is another way of testing. We can write. Right, let us write one more test case and to see if the price is present in the product which is returned. So I've added one more product, Galaxy S22. The price is 800 and there's 100 quantities because, as I said, the sale is coming up. And if you want to check this, what you can do is um, again self.assert in, uh, 800 is the price, data dot values, and because this I think returns, we need to convert it back to a list, and list take the 0th element, and then I think we have to print the price. So let's first try this test. I'm not sure if it will work or not, and I think it has failed because int is not subscriptable. So let us see what happened here. So what I'm going to do is I'm just going to print data dot values and convert it back to a list. So let me run this, and price, okay, I think here I need to give 0 because we want the 0th element, and on this I get to call the extract the key called as price. This should run now, and let me copy this here instead of data.values. And if I now run this test case, it's still failing for some reason. Int is not iterable. And if I just run the single test case, if you see, it is returning 800, and I was doing an in comparison. So in comparison won't work. We have to do an equal comparison because we are returning a single value, and in comparison only works as I said, when you're searching for, or here when you're searching within a list or whether you're searching within an iterable. And because this was int, we did an equal comparison. So this is a working of a test case. So this helped us understand or uncover one possible bug, that is we're not returning the data correctly. And secondly, we also got to check if we checked the add method, we checked the I think we check the price of the product as well. And I think there's one more thing which we can write: search product by name. So currently, what we've done is we've not been able to we have not tested this method. So firstly, I think what we need to do is we also need to correct this return method. I think it was again similar, and it only return the price and the quantity, but we don't want that. So I'm going to correct this. I'm just going to copy this return statement. And let us now test the addition of the test search product by name works or not. Search product by underscore name. And let me again, I have to just copy this. So let me create a product, and I've created a product called a Samsung Galaxy, and self.assert. I can just copy this assertion as it is. But instead of calling this method, what I have to do is I don't need this anymore, and I have to do a product dot search product by name, and the name of the product is LG monitor, right? So now let us test this. So if you see, this test has failed, and why it has failed is because we've passed in Galaxy S2, and let's change that as well, and hopefully this test should now pass. Yeah, search product by product name is also working. And if you saw a failing case as well, that the test was failing for some reason because we did not given the correct name. So this gives us a fair degree of confidence that a product add search product method and add product method are working more or less as if you look at the test case, we have written 4 test cases, and there's a couple of lines which are repeating in each and every test case: the creation of the product and the add product. So this is something which we are repeating throughout the test case. Now this definitely can be avoided. Why do we have to write so many of these lines? Actually, some of these tests are not good examples as well, because we're testing basically the same thing here and here as well. But I think it does explain the couple of purposes which I'm trying, that is the naming of the test case and how the in assertions or equal assertions can work. Now is that this product and add product has been repeated. So is there a way to segregate this or abstract this out so that we have to create the product only once? And yes, there is, and that is where a test fixture comes in. So what I mean by a test fixture is that or the test case comes with two not two but more than two methods which are available, and they help us add set up the data. And the methods are the setup method and the tear down method, and the corresponding setup class and tear down class. So these are the 4 methods which help us set up repetitive test data. Now you might ask, why setup and why setup class, and why teardown and why teardown class? And the explanation is pretty simple. So the setup method runs once per test case. The teardown also runs once per test case, but the setup class and the teardown class method run only once per test class. So what I mean by that is, let us just initialize that setup, and what I'm going to do is I'm just going to do inside setup method. And we're going to remove all these test cases for now. I'm going to comment them out and not remove this. And I'm going to write the corresponding tear down as well. Tear down inside tear down method. And now I'm going to run this test case. So if you see inside test method, then it ran the test case. So let me just add a print here as well. Ran test case. And if I run this now, inside test case ran the test case, and inside teardown method. So the test case the setup setup method and the tear down method run once per test case. So if I just uncomment one more test case, and if I run this now, and if I run it again, so if you see inside setup test method 800, because we're printing this, and we can just remove this as well. Inside tear down, inside setup ran the second test case, and inside tear down method. So the setup and tear down run once per each and every test case. So if you write hundreds of test case, the setup method and the tear down will run once for every test case. So this is good enough. Now this entire setup, tear down, and the test case is called as a test fixture. This entire thing makes up a test case, and this is called as the setup and tear down are called as a test fixture. What they help us to do, so any repetitive information, for example, I think we're creating this product, what we can do is we can remove this abstract, we can abstract it away and just name it self.product, and then instead of having to write it here, what you can just do is self.product, and here as well you can use the self.product. So it abstracted away a few of our lines of code, and everything which needs to be set up, or everything which needs to be repeated, what you can just go and do is put it in the setup class. Similarly, any operation such as which needs to be done at the end of the test case, so imagine that instead of having the simple operation, you had a file operation or something like that, then what you can do with the tear down method is you can do a cleanup operation. So this is about the setup and tear down. Now similarly, we saw that the setup class and setup tear down class also exists, and the way to do them is they are class methods. So add class method def setup class cls, and print inside, wow, I spelled inside wrong, setup class, and spelled class wrong as well, and add class method def tear down, print inside tear down class. Now let me run the test case again. So we have two tests uncommented, and if you see, inside setup class only runs once, and inside teardown class runs only once, but setup method are run once per test case. So no matter how many test cases you write, the setup class would be run only once, but the setup method would be run multiple times. So what would you put in a setup class? Anything which is expensive, such as database operations, file read write operations, which you need to run only once per all these test cases. You need to do it in the setup class, so that makes the test faster and costs us less memory. But anything which is smaller, less memory, less memory costing, less time consuming, you can put it in setup. So for each and every one of these test cases, we have a new, less memory costing, less time consuming. You can put it in setup. So for each and every one of these test cases, we have a new instance. Which we're going to do is we're going to take a quick look at what the arrange, act, and assert, what arrange, act, and assert is in a test case. So each and every test case, if you see, let me remove this. I don't think we need that anymore, and let me uncomment these tests so that I can just push this code to the GitHub repository once this tutorial is done. Now, what we're doing here in each and every test case, or at the heart of each and every test case, is the arrange, act, and assert. So these are the three key parameters which each and every test should have, and each and every test should have only one of them. You should arrange, act, and assert only once. So what I mean by arrange is arranging the test data. So what we are doing here is essentially the arrangement of the test data. We have created a product here up in the setup, so that arrangement is already done. Then we are adding a product, so that is we are arranging the data. The second thing which we are doing is assert, not assert but act. So let me pull up the act as well. So we have combined the act, but let me just extract it here and take data is equal to self. So this is the act part. On the data which we arrange, we are acting. That is, we are searching or we are calling the product method. I think the good way to do this is call it the unit under test. So on this arranged data, we are doing some act, that is, we are calling the search product by name, which is the unit under test. And the last one is the assert. We are asserting if Galaxy S22 or the name is present in the data which was returned. So a good test case should only have one of arrange, act, and assert block. So each and every test case should only have one of these. You shouldn't have multiple ones. So if I just do this, and if I just do another call, and if I just do another one, so it has multiple arrange, act, and assert blocks. It has two of them. So this is not a good test case. Imagine if your test case fails here. Imagine something goes wrong in the search product by name if the logic is buggy, or if something goes wrong in the add product, your second test case will never run. So that is the problem of having multiple arrange, act, and assert block, and a good test case should only have one of them. That is, each and every test should firstly have a meaningful name, and secondly, only a one arrange, assert, and arrange, act, and assert block, so that it only tests one and only one function. Is parameterization of test. So what if we want to pass multiple parameters and test the output against each and every one of them? So what we have done so far here is we have created three products and three distinct quantities and price, but we have done them in three test cases. What if you want to test multiple products in a single go? You can do that as well, and for that I've written a simpler function, no, because we want to concentrate on parameterizing the test rather than. Let me clear this as well and minimize this, because we want to concentrate on parameterization, the parameterization aspect rather than the complexity of products and all. So I've written a simple function which takes in two integers a and b and returns the sum of them, right? And let's now write a test case for that, and let us parameterize the test. So class test add two numbers, inherit from the unit test case, and def test uh, return add addition of two numbers, right? And let me just pass this test, so just to make sure it's working. And again, I'm going to put myself to the pain of writing if name equal to main unit test dot main, and this is already showing a problem. Let me fix that and let me run this test case. So if you see, a single test case has run and it has obviously passed because we've not done anything. Now let us call, let's create an instance of this, uh, ins is equal to uh, return sum of two numbers, and ins dot return sum of two numbers 10 comma 20, and on a self dot assert equal, it returns the sum of two numbers. So by default 10 and 20 should be 30. So what I've done here is I've created an instance of the return sum of two numbers class, and what I've also done is called the return sum of two numbers method. I've passed in the arguments 10 and 20, and it should obviously return 30. So let me run this Python test case, and this is passing as expected because 10 and 20 is 30. But if I just do 10 and 40, this will complain that 30 is not equal to 50, and which is fair. And so let me correct this and run it again. Right. What if you want to pass multiple? If what if you want to test this against multiple values? That okay, a single value is not sufficient enough. There's a couple of ways you can do this. You can just write another test case and pass. You can just write another test case and pass in test return two numbers too, something that's a meaningless name, and give it the other parameters which you want and run this. This is also okay, but this is a bad way to do it. We ran two test case which test the similar functionality, which is bad. So the correct way to do is to parameterize this test. And what I mean by parameterization is you can use this special subtest context manager to pass in multiple tests. So what I'm going to do is, firstly, I'm going to create a list. This is okay. Test case is equal to, what we have to do is we have to create a list of all the values which we intend to test. So 10 comma 20, and the sum would be 30. Next, if you want to test 5 and 10, the sum would be 15. And nextly we'll do some bigger numbers, 85 plus 15 should be I think 100. And what you can then do is for number 1 comma number comma number 2 comma sum in test case. Let's make it test cases, so just to make it more meaningful, here I can pass in number 1, number 2 and the sum. If I now run this test case, let's see what happens. Oh, it failed with a very long error. This was not expected. So let's see what happened. Oh, okay, I know what happened. We just missed the bracket. Right. If you see, it ran a single test case. Although we gave it 3 inputs, it ran a single test case. Now let me just fail one of these test cases. So 10 and 15. Let's make it 20. Right. And let me run this. Now if you see, it has failed that the expected value is 20 but actually is 15, because 10 and 15, 10 plus 5 gives you 15, but we got 15 instead of 20. So this test case has failed. That is, it expected the output to be 20 but it only got 15 because the function is correct but this test case is wrong. And what happened as a side effect is this third test case did not run. Right. So although we have parameterized this a bit, this is not the correct way. This is still running as a single test case. And to correctly parameterize it, what you have to do is you have to use uh, self.subtest. And to the subtest, we have to give a proper name. So let us give it number 1, comma number 2. So basically what we're doing here is numbering each and every test. And here, let us give it the name sum as sub t. Actually don't need to give this name. And if I now run this test case, firstly, let me correct this. Let me make it 15. And if I run this test case now, if you see, it has run 3 test cases as opposed to the first one. So what I'm going to do is, just to be clear, return to numbers without subtest. And if I run this now, if I run both the test cases, if you see in the first instance, without subtest, it has run on a single test, but in the second instance, it has run 3 different tests. And it will also show you what test it has run. And what advantage it gives you is if I just fail deliberately one of these tests, and if I now run this test, it'll run the other 2 tests, but only the problematic test is the one which is failing. So this is how you parameterize tests properly with the subtext context manager. Right. After discussing the parameterization, we're now towards the end of this module, and we're now going to talk about mocking. Is basically a strategy which involves multiple internal strategies, or there's multiple ways in which you can mock data by creating stubs, fakes, dummies, spy, or monkey patching. So what each and every one of these means, we will see via examples. And the first one which you're going to look at is the start. What I have is an example. So this is a warehouse alarm class and this is a sensor class. And what the warehouse alarm class does is it triggers an alarm if the temperature exceeds this low limit or this high limit. So if the low temperature becomes greater than the current temperature, that is, say the temperature becomes 9 or 7 or 8, then 9 becomes this 10 becomes greater than 9. And similarly, if the high temperature is less, that is, the temperature becomes 20, then 20 is obviously greater than 18. Then what it will do is this alarm will be triggered. Now to read this temperature, we rely on a different class called as sensor. So the sensor is which to segregate duties, there's a separate class which does the temperature reading for us. And then we have exposed a property which just gives the current state of is alarm. By default, the alarm is off. And so we have written a test class as well, test warehouse alarm. The spelling here is correct, the spelling here is wrong. So I think let's correct this and let's correct it here as well. Yeah. So this the default test, what it simply does is it tests is by default the alarm is false. That is, at the initialization, that is when we set up the warehouse, the alarm is not blowing or it is not constantly sounding. So let me just run this test case first to see if the alarm is working. So we tried all the test case, but I think the one which you are looking for is alarm is off by default. So this is the one which you're interested in, and it is working as expected. That is, but the default value is false, and we've done an assert false, so we know that the alarm is off by default. Imagine that this sensor class, which it relies on to read the temperature, is not implemented. That is, someone else is working on this and they have problem with the IoT device which reads the temperature or something like that. In that case, you don't want to stop the testing of this warehouse alarm class. And what you can then do is we can use a stub in that place. So what I mean by stub is you can just write a mock class, mock sensor, yeah, and what you can do is you can just pass it always returns the value 15. Yeah, I've done a sensor. Yeah, I think this is the correct mock sensor. So this is a class I've written, and what it always does is def return, just give it the same name as this, read current temperature, not that but def. And so this is what a stub looks like, and basically what we've done is, because this class is not ready, we've created a new class and we've hard coded the return current temperature method to always return 15, so that our testing goes as expected. So what we can then do is, now the problem actually with this class, warehouse alarm class, is that this sensor class is hard coded so that it is always expecting this sensor only. So now if I just try to pass say uh, if I create an instance of this mock sensor, and if I try to pass it sensor is equal to sensor, it will complain. If you see the problem, what we've done is there's a hard coding here. There's no loose coupling. That is, this warehouse alarm always expects this sensor class to be present. Now, so this is another advantage of testing, that this has helped us expose a flaw in the design. That is, this since the sensor class is hard coded, the problem with this approach then becomes that we cannot pass in a stub which we intend to do that. So a good way to work around that is give it an additional parameter called as sensor, and by default make it as none, and then what you can do is sensor or this. So what this test has helped us expose is the design flaw in this warehouse alarm class. That is, because the sensor class was hard coded, it was only ever going to take in this sensor. So if the development of this sensor is not complete, you're basically stuck. You can do nothing. So this is an advantage of which testing gives. So writing a test case helped us understand or expose a flaw in our code. So we've corrected that. What we've done now is we have given it an optional argument called a sensor. With this new approach or rewritten code is, I can pass it the sensor as an argument, and let me run this test case. So if you see, the test is now passing. All the tests are now passing, and what we can then also do is, on this sensor, um, we can then use this to test our high and low temperature. So this is mock sensor, which returns a high temp, and let us return 20. And similarly, I'll create another stub which is called as high temperature, mock low temperature, and let us give the value 9. So we have written two stubs, and why they're called as stubs is because they don't pack in any functionality. They are just stubs for this particular class or replacement, and they return hard coded value. So let me just correct this. I don't think we need this, and because I've made some changes, let me run the test case, and they're still passing. And now what we will do here is we will implement our test is alarm activated for high temperature. That is, basically we will call this mock high temperature class, sensor is equal to mock high temperature, and alarm is equal to warehouse alarm, and to this we will pass sensor, the sensor which we created. And now on this alarm we will call dot check current temperature method, and self dot assert. The alarm should now be on because we have passed it a high temperature. So alarm dot is alarm on. So what we've done in this test case is we've created a stub for ourselves, which is always which is always returning a high temperature. We've created that. We have created a warehouse alarm class, passed it this stub, and then using this stub, we have called the check current temperature method. So this sensor class would be an instance of this, and when we give this sensor dot read temperature, instead of calling this current read temperature, it will call the read temperature from this method. And if I now run this class, this test should still pass. But if I just change this to say maybe 15, this test will now fail. So if you see, this test has failed because false is not true. Obviously, because the temperature was not exceeding the high temperature, this condition was never satisfied, and hence the test failed. So let me correct this to 20, and the test is now. So just to recap, what happened here is because the sensor implementation was not ready, what we did is we created a stub. Now again, why it is called a stub is because it doesn't pack in any other functionality. It returns a hard-coded value for this particular function, this particular method. So we created an instance of this class, and we passed it to the warehouse alarm. And when the warehouse alarm called the read temperature, instead of going here, what it did was is it went to the read temperature of the mock sensor class, and on that we checked the is alarm is on. So because the temperature was exceeding the 18 limit, it turned the alarm true, and this is what we're doing. We're checking if assert true alarm dot is alarm on. So this is how stubs can be used when your production classes, when your other classes which your code relies on are not. So the next mocking strategy is called as monkey patching. We'll discuss fake dummies and spies in after this, but because monkey patching and stub are pretty similar, we will discuss them first. So what we did in the test stub class is we modified the design of the high warehouse alarm class and to take a default class as an argument. So this is okay, but consider a scenario where you're not allowed to do this. So we have taken the same example, but here you're not allowed to pass in a default argument or change the implementation of the warehouse class. So in that case is where the monkey patching comes in. So in monkey patching, what you're doing is basically you're using a special syntax with this patch as a context manager. The patch is imported from unittest.mock, and uh, what we're creating essentially is a test class. So and the test class which you need to mock is taken from this module. So this is what the string says, and the syntax is a little bit off. I think we have to pass the class name as a string, give the context manager proper name, and then use the special keyword again, which is the mock class, which is again available as part of unittest.mock. So this will give you a blank instance. To this blank instance, what we are doing is assigning a method called as read current temperature, which is also the method which we intend to test, and this is always returning the value 20. So instead of writing a stub which we wrote here, what we are doing is we are creating a mock class. To it we are assigning the method and the value, and what we then need to do is this test class instance would be this test class or this patch which we created would be assigned this test class instance value. So this test has failed because we've missed one value. So this test class dot return value. So basically what we're doing is this test class which you created, sensor, is always returning this value, that is the value 20, and this method. So if I now run this test class, if you see, the test has passed. So just to recap what happened, because this is a lot to process, right? So the first assumption which why we use monkey patching is unlike the test stub, we are not allowed to change the implementation of the warehouse alarm. So we had to simulate somehow the implementation of this sensor class, and to do that we use a strategy from the unittest.mock. We imported mock and patch, and what we did is with the special context manager as syntax, we initialized a test class, and what test class we initialized from test monkey patching, which is this module dot sensor. So this is the class which we initialized. Then we created a mock class instance, which is test class instance, and to that we assigned a method called as read current temperature, and that method will always return the value 20, which is higher than the higher temperature bar which we have set of 18. and the test class would the test class dot return value would was assigned this particular line. So basically the 20 got assigned to this test class dot return value. So this sensor or this current temperature method was simulated and we assigned it to the test class. The rest of the functionality remains similar because these lines of code basically initialized this sensor class for us. So that is what monkey patching did. Now if I run this test case, you see the test case is passing because the value 20 was available to it. So this is one syntax of monkey. Now there's another syntax as well, which is a little bit more readable. So what you can do is you can use the at patch decorator. So we'll now implement the low temperature, and in the at patch decorator, this remains similar. We have to give it the name, the name of the class which we need to patch, or the one which you need to simulate. This test class then needs to come as an argument here. So instead of having this whole lines, which is I feel a little bit untidy, what you can do is just pass this test class sensor, and the rest of the lines remain similar. You can just copy paste this. So this is a much more concise syntax, and let me copy this as well. And instead of returning 20, let us now return 9 because we want to test what do you say, the low temperature class. So if I now run this test case, if you see, okay, it's not run the test case. uh, for high temperature, let's run this particular test case, and if you see, the test low temperature is passing because it is the correct temperature. So these are the two ways of doing monkey patching, and you can use this strategy, this mocking strategy, where you're not allowed to make design changes, or there are hard coupling of classes or parameters which you need for testing, or hard dependencies. So let us quickly talk about fakes and dummies. We don't have examples for these, but a fake is used where you there are high performance, what do you say, high performance or high memory involved objects which can be replaced. For example, if you have if you have file operations, or if you have database operations, or you're connecting to external web servers, you can replace those with lightweight servers, or you know if there's a file, you can use the string IO method, which simulates the kind of the behavior of the file. And so that is what fakes is. So it's more like stubs, but instead of simulating simpler logics, fakes are used to simulate high time consuming or high memory consuming attributes, such as database connections, servers, or say file operations. Well, if you just to give you an example of what a dummy might be, say we are in this warehouse alarm class, and one of the parameters is optional. So if I just do sensor, and if I make, we'll go back to this none, so sensor or sensor. So it'll either take in the none parameter or the sensor parameter. So basically this is a default argument. When we create the warehouse alarm class, we can just pass in none and be done with it. So it doesn't really need a sensor class to work with. So this is an example of a dummy. We can just when you create the warehouse alarm class, you can just pass sensor is equal to none and be done with it. So this is how a dummy looks, right? The last strategy which we're going to talk about is something called as spy. So the spy is similar to stub, but it actually not exactly similar to a stub, but it tests whether the functionality which you are implemented calls a certain methods or not. So it basically checks the behavior, or it kind of spies on the behavior, whether what we've implemented, or what we are saying we've implemented, is actually the is actually the functionality we have implemented. We're not just saying it for the sake of it, but we're actually doing some checks. Example. And what I've done is I've written a class called as my service, and another class called as login checker. So what the my service does is it allows us to log in with a username, and if the username is present, it greets the user. If not, it just asks us to log in. To test this, I've written a test do login, and test is username validated. So let me run the test case first, just to ensure that whether this login functionality is working or not, whether if a name is supplied, it is greeting me or not. So if you see, I've done an assert equal. So if I just print the return value to remove any conclusion, and if I run this test case, so if you see, the return value is Jaideep, that is, this do login is working as expected. Now if I just write this test do login without username, and if I don't supply a username, this test case should fail. So if I just run this test case now, if you see, it is failing because it required one. Let me make this as a default. So if you see, testing has helped us to expose behavior, buggy behavior. So yeah, just to reiterate advantages of testing. So if you see, one of the test cases failed because the assertion has failed. Please log in is not equal to hello Jaideep. So it was expecting the message to be please log in, but it got hello Jaideep. Here, please log in. And if I now run this test, this should hopefully pass because we are now returning, obviously we have not passed any name, and because we have not passed a username, it will not go in this if block, and it will return this please login. So this code is working, but then where does the spy come in? So where the spy comes in is we're taking the username, but we're not actually validating the username. Suppose there was a separate login checker class which would do validation of the username. Right, so these two tests are working. Now we need to check another behavior. So what we're basically doing here is we're checking just if the username is present, we're allowing the user to log in. But we've never really checked if it's a valid username. To check the logic of whether the username is valid, we are using a login checker class. And we have a third test written for this. Now let me just run this third test case. So if you see, the third test case has failed. Is valid username is not called. So this tells us that the is valid username method is not called. Spy basically does is it spies whether this method which we say is supposed to be called. So we are actually in this test, what we're trying to do is we're trying to tell we're trying to test if this method was actually called. But because we have not obviously made a call, this test has failed. So this is how spy works. It actually spies whether the functionality which we claim here, we're claiming that this logging checker dot is valid username is called with the username which is supplied. So basically what we're trying to say is that this method is called with this username, and where it is called in the my service. But if you see, the my service never calls this, and this is what the assertion is failing, or this is what the spy is complaining about, that okay, you told me that this username there's a method called for username checking, but you have not implemented it. How to correct this is pretty simple. What you have to do is you just have to go and click this and call this. So not just this, but is valid username. So what we're now doing is we're calling the is valid username method, and let us now run this test case. So if you see, the test case has now passed. That is, this spy or this particular line, what it did was it actually checked if this method is called. So this is how spying works, and it helps us understand if the behavior which we claim to be is actually implemented